Is there a perfect world where a water clarification unit can be compact, durable, economical, and capable of operating in all climate extremes while maintaining the same level of efficiency? These are questions asked by everyone who, in one way or another, is tasked with implementing water usage solutions in the industrial sector. We have our own answer: DYCLAR's unique dynamic water clarification technology. According to World Bank forecasts, the global economy awaits thirst, as the world will face a serious shortage of clean water by 2030. The reasons for which includes the industrial polluting of fresh water. The problem has been one of truly global proportions for a long time now. According to 2017 data from UNESCO, 80% of wastewater returns to the global ecosystem without treatment, while only 20% is purified or treated. It should not be surprising that several generations of water purification and treatment technologies coexist on the market today, from those based on traditional technologies to those engineered using nanomaterials. The developing engineers at DYCLAR have found an opportunity to combine reliability, modern materials, efficiency, and cost-effectiveness in the new DYCLAR dynamic clarification technology installations. Let's compare the widely implemented technologies of ultrafiltration and ballast sedimentation with DYCLAR. The first criterion for choosing a water treatment technology solution is its resistance to the degree of source water contamination. Efficient water treatment systems usually means ultrafiltration. This technology is sensitive to inlet water quality. In this regard, water with high turbidity and high suspended content shortens membrane life. The cost of membrane replacement may be as high as 40% of entire installation cost. Therefore, a paradox arises. For ultrafiltration, water must first be clarified. In addition, the performance level of the membranes is not very high. One module cleans from 2.5 to 4 cubic meters per hour, meaning that a large number of such modules are required. In a ballast sedimentation plant, it is possible for impurities to slip into the area with purified water, as there are no physical barriers constraining pollutants. Such water is not suitable for release into the drinking water supply system, or for continuing treatment using reverse osmosis technology, meaning that after passing through the sedimentation zone, supplementary filtration is necessary. For comparable performance, at least 3 rows of ultrafiltration units would be required to ensure the continuity of the water treatment process. Additional ultrafiltration requires mandatory preliminary filtration. Ballast sedimentation requires a mandatory post-treatment unit. This means that the area occupied by additional equipment will also have to be considered when making comparisons. Multiplication by 2 or 3 is also required because all the installations have backups to ensure that capacity does not drop during maintenance periods. DYCLAR's systems effectively use not only the area, but also the volume of the building. Choosing from among the different DYCLAR models will help to fit the installation into the existing premises. Additionally, the optimal types and sizes of the DYCLAR installations can be selected depending on the volume and quality of the source water, and not only the available area. There are several versions of DYCLAR installations: stationary, block modular, and mobile. The choice of a solution determines the period needed from the start of work to the commissioning of the unit. With every moving part, the risk of failure of any installation increases. In addition, sand entering the system acts as an abrasive, accelerating wear. The risk of mechanical failure is therefore high. However, our technology is able to withstand hydroblows, the chief threat to ultrafiltration installations, something others cannot. If a membrane cannot withstand a hydroblow, its fibers will simply rupture. DYCLAR's inert layer makes it possible to compensate for hydroblows, ensuring operational reliability. All of this is possible thanks to DYCLAR's know-how. DYCLAR's dynamic clarifiers work at the micro and macro levels simultaneously. Chemical reagents are released in proper doses to facilitate the preliminary coagulation of colloids and suspended particles, and help activate the surface layer of the polymer filter media, effectively turning it into a magnet for dirt flakes. The filtering bed is not monolithic, but a large molecular membrane permeated with a myriad array of filtering microchannels. The DYCLAR regeneration procedure requires only water and air. Flushing removes all impurities from the filter layer. The principles used in the operation of the unit reduce water consumption for its regeneration. How to offset initial capital and operating costs for each installation. The cost of treated water depends on the type of equipment. Cost structures will vary. Ultrafiltration requires high costs for membrane flushing and replacement, while ballast sedimentation requires reagents and expensive sand. DYCLAR is a new generation technology with reduced maintenance costs. Thanks to technological solutions, DYCLAR not only fulfills its direct responsibilities, but also increases the profit margins of the customer's business. Thanks to DYCLAR, more than 76 million cubic meters of water are purified every year. From design to turnkey construction, every aspect of our installations has been optimized during the over 20 years of our company's operations. DYCLAR's dynamic clarification technology is already in use by more than 60 enterprises.